Hello everyone. Four rods, each of length L, have been hinged to form a rhombus. Vertex A, as you can see, is fixed to a rigid support. Vertex C is being moved along the x-axis like this with a constant velocity v as shown in the figure. The rate at which the vertex B is approaching the x-axis, there are certain physical constraints in this problem. As the point C is moved along the x-axis, point B will have a vertically downward velocity and a horizontal velocity also. So we are concerned about the vertically downward velocity. So we have to find the rate at which the vertex B is approaching the x-axis. At the moment, the rhombus is in the form of a square. So we will start with the square and apply the physical constraints. So we have the diagram here already. So this is a square and this end is A, its velocity will be 0. This end is B, this end is C, and this end is D. So C is moving with the velocity V, that is given in the problem. So if we fix the origin at the point A, 0, 0, the coordinates of C can be written as x, 0, and this height we can simply take as y, and since it is a square, this angle will be 45 degree. This angle will be 45 degree. And if total length of AC is x, if this point is E, then EC will be x by 2. And clearly we can write that tan 45 degree will be y divided by x by 2. So let us start with Pythagoras theorem. This length L is fixed. So we will have y square plus x by 2 whole square equal to L square. And so we can write it as y square plus 1 by 4 times x square equal to L square. And on differentiating both sides with respect to time, we get 2y dy upon dt plus 1 by 4 times twice x into dx by dt. And since L is a constant, the differentiation on the right hand side will yield us 0. So 2y and dy by dt will be the vertical velocity of B, the velocity with which it is approaching the x-axis. So let us take it as Vy plus this will be x by 2 and dx by dt will be V only. So this will be equal to 0. So we have from here Vy equal to negative of x times V upon 4 times y. Also from simple geometry we can write tan 45 degree in this triangle will be y upon x by 2, which is nothing but 2y upon x, and tan 45 degree is 1, that means x will be equal to 2y. So x is 2y, so Vy we get minus of 2y into V upon 4y, which will give us minus of V by 2. So minus sign indicates that the velocity is downward, which should be as expected. This point will have a downward velocity of approach, and though it will have another velocity also in this direction, but that is not our concern here. So if we are interested in the magnitude of the velocity, so mod of Vy will be V by 2 simply. So the point B will approach the x-axis with the velocity V by 2 if the point C moves along the x-axis with the velocity V. So that is it. Simple constraint problem. Thank you very much.